Hi everyone. Imagine if you could walk into the SAT knowing how to solve every single math question that they can possibly throw at you with 100% confidence. In this video, I will be showing how to use Desmos and going over 5 topics that appear in the hard SAT math second section. Also, in this video, I will put in the bottom the little tabs where you can go and see each individual section. If you already know one, you can skip through to the next one. So I'll get started right now. So the first thing that pops up a lot on the SAT math is the product and sum of solutions. So the product and sum of solutions, so I'll go over the sum of solutions. Solutions is just like the sum of the two solutions. So if I was in Desmos and I was just writing the equation x squared plus 2x plus 1, the solution here would be -1. And then say if it was -10, the solutions here would be this and this one. And then what you would do is you would just add these together to the sum of solution. But there is a shortcut to be able to get to the sum of solution a lot quicker, and that is what you can do is the sum of solution is actually equal to -b over a. And you know the standard formula for quadratic is here is ax squared plus bx plus c, so ax squared plus bx plus c like this, or this one here is a in front of this, b, and this is c. So all you do is just -b over a. So in this scenario, you would just do the -b, which is 2, so just be -2, and then a, which is just 1. -2 over 1 would be the sum of solutions. So then here, if I were to go in Desmos, and then I would just copy these two over here, and then if I would just put this one and this one, add them together. Let me erase this, see it better. Here, this plus this would actually be -2 too. So that is just another way to do it, and that is the sum of solutions. So another thing, the next thing is actually the product of solutions. So the product of solutions is just like it sounds, is the solutions multiplied together. So here in this scenario, what we would do instead is just do this times this. So it would be this -0.9999. So the shorthand for the product of solutions is c over a, which once again is the ax squared plus bx plus c, where this one right here is c and this one right here is a. So it would just be -10 over 1, and here is -10, which is what this would be rounded. This is just more of an exact one because it is actually graphed and they got the exact points not rounded, and this is just rounded, but they would accept this because it's the same thing as it rounded. So now let's go to an example problem here. Let's go to this example problem here, which is testing the sum of solutions. So go pause the video real quick and try to solve this, and hopefully you solved it by now. And now I will be going over it. So the question is, what is the sum of solutions to the given equation? So if you know from before, the sum of solutions is -b over a. So what I'll be doing here is I would just be doing -b, which is 40, and a is 1, so 40 over 1. So the sum of solutions here is just 40, so the answer here would be D. Now for the next topic we're going over, which is like minimums and maximums. So like, you know, you can type anything in Desmos. You can type, say, once again, x squared plus 2x plus 1. This here, the minimum here is -1, and the maximum, there is no maximum because it just keeps going on forever unless it has a certain x value. So say it's just between here and here. So what I could do is I could just type in these curly brackets here between -2 less than x less than 2, and then here it will just show here, and the maximum here would be this number. But usually it's just like whichever one is where it ends, where the vertex is, which is like right here. So that is like the minimum, maximum, and all you can do Desmos is you just plug in the equation, and then you can just look at the minimum or maximum. It's pretty simple. So now let's go look at another example problem. This one here is good. So to do this, I'll give you a second to do this problem real quick. Okay, so hopefully you paused the video and done the problem. Now I will be going over how to do it. So what you would do here is says the given equation relates the variables x and y. For what value of x does the value of y reach its minimum? So it's just basically asking for where is the minimum. So one way you could do this, you could find the vertex of it, but that would be that would take a little more time, and you can make a lot more mistakes doing it that way. What I would do, I just plug it here into decimals, x squared minus 14x plus 22. So now here, I can see that, okay, the minimum here is here at negative 27.7. So the value of x here is just 7. So your answer here would be 7. So now for the next topic. The next topic here is factors. So on the SAT, sometimes they'll give you an equation such as like this, x squared plus 7x plus 6. This is just a random equation. And then they'll give you like 4 options here, A, B, C, D. And then one of these will be a factor of it, and then it'll be asking you which one is a factor. So say here B would be x plus 3, x minus 2, x plus 6, and then x minus 4. So this I just came up with this right now. So to see which one is a factor, what you could do is you could factor this out. And this one here is pretty easy. You could factor this out pretty quickly. But on some other harder SAT problems, they do have it. They do make it really hard where you can't factor it out very quickly. It takes a lot of time. So what you can do is actually you can go into decimals like this, and you plug in first this equation right here. So x squared plus 7x plus 6. This gives you this line right here. And what these factors do is actually these factors will intersect here at the x-intercept of this one right here, intercept at the exact same spot. So here, if I were to plug in x plus 3, it does not intercept here, right here, or right here. So I know that this is not the correct answer. If I do x minus 2 here, once again, it does not intercept at the exact same points. So that's not the answer. Here, if I do x plus 6, here it intercepts at the exact point, which is right here. So this would be the answer in this particular case. And then just to double check, you would put x minus 4 and see that that one is also not right. So the answer there would be C. So now for an example problem. So like this one right here. So this one here is kind of a more difficult one, but I'll give you a second now to do it. Just pause it, try to do it your best, or try to see how to do it, and then I'll come back and explain it. Okay, hopefully you did it. So now what to do, we'll read the problem. It says if k minus x is a factor of the expression negative x squared plus 1 over 29 n times nk squared, where n and k are constants and k is greater than 0, what is the value of n? So here you're trying to see what the value of n is in this equation, but you know this is a factor. So what I would do, what you would do in this scenario is you would just first type in this equation right here into decimals, negative x squared plus 1 over 29 nk squared. So there's no value for n and k, there's no value. So what I would do here is, because k is in both of these, when k is a constant, you can set that to any number you want. So I'm just going to set k to like 4. And then I'm going to type in this here, k minus x. So now if I look at it here, they don't intersect the exact spot, so n can't equal 1. But because it's multiple choice, I would just plug each of these ones into n to see which one it intercepts at the exact spot. So here, I would plug in first negative 29, and see it does not, because this one's the one moving, it does not intercept here, so that can't be the answer. Then negative 1 over 29, here once again it doesn't do it, and then positive 1 over 29, doesn't work, and then here just 29, and here you can see it intercepts at the exact point, so this is the factor of it. So the factor always goes through at the exact point. And this only works, by the way, if the factor of it, like here, is linear, meaning it's to like the first degree here, and not exponential. If it is exponential, what you have to do is you have to just like factor it out. So just scale it down. So like scaling it down would be something like this. Say if it's like x squared plus x. What you do here, the x squared equals x to the 1 times 2. So you can just take out the squared, and then in this problem here you would get rid of the squared too, so it would just go down to minus x, and then you'd plug it in. So if that would happen, then that's how you would solve one of those. But I'll get into those at a different time. Now the next thing here to go over is vertex formula. So vertex formula is like this. It's in the form of a and then x minus h squared plus k, where h comma k, that is your vertex right there. So this here you can convert to the ax squared plus bx plus c, where if you just expand this out, it would actually equal to this. So you can use that if you're given the vertex, you need to get to here, you can use that to solve it, because not all the time when you do this, you can use regression to get to here. So for example here, I'm just going to show you how the formula works. Ax minus h squared x squared plus k, and then I'll just do all of these, and then see a is equal to 1, and the h and k, they're both 1. Here the center is at 1 1. If I change this to 5, it is now 5 1, then 10 here, now it's 10 5. So you get the point. Now it's just here, this is the vertex here. It's pretty simple. So now I'll go into a pretty difficult example problem. So here's the example problem. I'll give you a second to try to solve it, and then I'll go over it. Okay, so now hopefully you solved it, and now I'll go over it. So this one here says, in the xy plane, a parabola has a vertex 9, negative 14, and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, c are constants, which of the following could be the value of a plus b plus c? So most of you guys, when you read this, you probably went over this point that here intersects the x-axis at 2 points. This is very important because you know the value of a if it's positive or negative. Because here 9, negative 14 is here in this quadrant. So if it were to intersect the x-axis at 2 points, it must go up this way, which means that a is a positive number. So now you know that a is positive. That is actually very helpful to solving this problem. So now, here what most of you probably did is you probably said, okay, well I have this in vertex formula, and it wants me to put in this formula, so I would just use regression. So I would just go here and write this in vertex formula. X1 minus 9 squared minus 14 equals ax1 squared plus bx1 plus c. And then you would define x1 equals to 10. Here's one more of these. And then here you would get it. But then, if you were to say a plus b plus c, it equals negative. It's not none of the answer choices. And then if say a equals 1 or 2, it goes up and it's not even negative, so that doesn't work. So here what you actually need to do, how you actually solve this, is in this vertex formula here, you have to expand it out and then add the numbers. So I'll show you here what I mean. So what you need to do here to solve this one is actually write it out. So here 9x minus 9 squared minus 14. So this here, I'll expand it out, so I have to FOIL this. So to FOIL it, remember you just multiply each number by each other. So it would look like something like this: a times x squared minus 18x, and then plus 81. And if you want me to go over these basic algebra things, please comment down below to see if I should make a video on that. So here, and then negative 14. So this is what it equals. So if you add the a to everything, it'll be ax squared minus 18ax plus 81a minus 14. So if you know here, this here is the c, this is equal to b, and then this here is a. So now what I can do is I can actually add all these up because there's no x's, they're all common a's to get the answer. So here what I would do is it would be a minus 18a plus 81a minus 14. So now we just combine like terms here. So a minus 18a, this is minus 17a, and then plus 81a is 64a. So this is 64a minus 14, and that is should be equal to one of these answer choices here. So like I said earlier in the beginning, that it's very important that A is positive. So because I know A is positive, I can actually just plug in each one of these answer choices to see which one gives A as a positive value. So right here, what I would do is I would just plug this into Desmos. 64A minus 14, and then use regression here, is equal to negative 23. Here, this is a negative number, so A can't be negative, so that's not right. If I do negative 19, it's negative once again. Negative 14, it equals 0. And for 80, if A were to equal 0, then it would just be a linear line and can't intersect at 2 points. So that doesn't work either. And if it equals negative 12, A is a positive value, so the answer here is negative 12. This is actually a very difficult problem, but once you see it and get the hang of it, it's actually not that bad. Now I'll be going over one more problem. This one here is a very difficult problem to solve by hand, but actually with Desmos, it makes it very easy. So real quick, I'm just going to go over with Desmos, with regression. So if I had something like 26 over A plus 5 over B, equals 1 over C. So just say, for example, I had this, and I need to express this in terms of A. What I could do here in Desmos is I would just write here 26 over A, and then plus 5 over B, and then use the tilde instead of the equal sign, and then 1 over C. And then out here I would define A is equal to 4, and then here I get values of B and C. If I'm doing this in terms of A, each answer choice would say like an equation of it in terms of A, and then what I would do is I would just plug each of those equations in, and whichever one equals 4, that would be my answer. So now to go into the example problem here is this one right here. So I'll give you a second to try it on your own. So hopefully you try the problem. Now we'll go over it. So the given equation relates to distinct positive real numbers w, x, and y. Which equation correctly expresses w in terms of x and y? So this one here, if you do this by hand, algebra would actually be very difficult, and you probably could do a lot of mistakes. It's doable, but you might do some mistakes, so it's better just to use Desmos. So what I would do here is I would just type this right here into Desmos, 14x, and then always put the 1 after the variable when you're doing regression with Desmos. So 7y1, and then the tilde equals square root of w plus 19, and you don't put the 1 behind the w because that is just a variable there, and it does not use it for graphing, so you don't need to do that. So then here I would just say w, I'm sorry for w, I said w equal to 4. So now whichever one of these ones equals 4 is the correct answer. So I would do square root of x1 over y1 minus 19. This does not equal 4, so that's not the answer. So now b, 28, 14. Here this one does not equal that either, so that's not the answer. Now x, y squared minus 19, x1, y1. That is equal to 4, so our answer here would actually be C. And then just to double check here, just to do last one here, it would be equal to 73, which is not the correct answer. So here, in the problem like this, if you ever see it, all you need to do is just find this, set values for each of these variables, and set it for one of them, have Desmos solve for the other ones, and then just write in each one of these equations and see which ones equals the variable you're trying to solve for. So it's pretty simple. So thank you for watching. If you have any questions, please comment them down below, and don't forget to like and subscribe for more SAT prep, and thank you for watching.